Okay, so for tonight's lesson, we want to be able to identify 5 different types of functions and graphs. And I asked you in your pre-assessment which one of these graphs that you could recognize already. And just about all of you were able to recognize our linear function or linear graph, which is going to be our first one here. And hopefully you're very familiar with this. This is a linear graph. Of course, it can be a positive slope where it rises from left to right, or it can have a negative slope where it's going down. So you need to understand that a linear function is something that rises and runs or falls and runs at the same rate. And hopefully this looks familiar for you. Most our linear functions are in slope-intercept form. Y equals mx plus b, m being your slope or your rate of change. This is telling you how much it's the rate is every single time. So like in this case, it's rising, run, and running, run. So the slope would be 1. So this is rising at a rate of 1, depending on what it's about. It could be meters per second, yards per minute, depends on the situation. But what I want you to be able to do is recognize that a line is linear, and most of you guys remember that line is in the first 4 letters of linear. Hope you remember that's linear. This one, most of you were not, not familiar with, which is understandable. You probably haven't heard it before. But this one is called absolute value graph. Okay, and most of you are familiar with the absolute value brackets. Okay, and hopefully you remember that absolute value, whatever is in these brackets, is positive. Okay, so so this is generally what you will see for a absolute value function. Now you might have like an x plus 3. In this case, we'd have 1, 2, 3, 4, 5. X minus 5 in this case in there. But the main equation is y equals in the absolute value of x, and then you can have some other mathematical operation going on in there. But that's the main idea. So we want to know that absolute value kind of makes this V. And so we're going to identify that graph as an absolute value graph. Okay. This one also, most of you didn't know, and again, this is a new one. This is called a piecewise graph. Okay, and you can kind of remember that because it's almost like it's in pieces. Piecewise graph, it's almost like it's got 3 graphs. If we can go from here to here, that's a linear positive slope. And then we have a horizontal line here, and then it's broken up into another line. So it's almost like it's got 1, 2, 3 graphs. And actually, there is no sort of standard formula for this because it would actually have 3 equations. We'd have an equation for this. And if you remember from earlier, this has a y-intercept of 0, and it looks like it has a slope of 4 over 1. So that one would be y equals 4x. And then we would have a whole different equation for this. This is a horizontal line at the 1, 2, 3, 4, 5. 5 on the y. So this equation is going to be y equals 5. And then we're going to look at this equation here, and then this one doesn't have a y-intercept, right? But it looks like it has, I can't read it because I put that red line on there. It looks like it has a slope of maybe the same thing. 1, 2, 3, 4 over 1. So that one also is going to be y equals 4x. So you would actually just list all these equations. So a piecewise graph, mostly what I want you to know for today, is a piecewise graph is a graph broken into pieces. It's got several pieces, and then its equation will be the equation for each part of that graph. Okay. The last thing we're going to talk about is this type of graph. Some of you said you knew what that was, and this is called an exponential graph. Okay, and if you think about how we use the word exponential, use it when there are great jumps in values. When you say, the rise in the stock market was exponential, it means it made big, huge growths. And if you look at it here, It makes, it's exponentially is bigger. It makes a small jump, a little bit bigger, a little bit bigger, and then it starts making giant leaps. So exponential is kind of like we think about 2 squared, and then you square that number, and you square that number, and you square that number gets big, 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 and it's not increasing at the same rate. It's making giant jumps as it goes. So exponential is I always call this kind of like a swoop, and it actually can be coming down the opposite way as well. And the exponential equation, the standard form, looks like this: y equals ab to the x power. So an exponential equation will always have the x as the exponent. Okay, and then we'll get into more detail later about what the a and the b values are. But you can recognize an exponential equation by having x as its exponent. Okay, and then some of you in your pre-assessment knew what this was. This is called a quadratic equation, and we're actually going to spend quite a bit of time on these quadratic equations. This is the standard formula that you will see for a quadratic equation. The highest exponent we'll have would be x squared. So if it has an x squared and nothing larger exponent than 2, you know it will be a quadratic. And so this is a rise. It's something that's got to come up and come down. In most of our math this year, they'll use situations like kicking a football. The football comes up, reaches the maximum height, and then comes down. Okay, so anything that's like comes up and comes down. Now this quadratic can also be flipped the other way, and then we'll have a negative out front here, so they can also come up and down this way as well. So mostly though, for the beginning of this year, we want to know that you have sort of a general idea of what each function is and be able to recognize in a word problem what it belongs to. So just to sort of recap, you should be able to tell me that a linear equation is something that goes up or down at the same rate. Okay, so it's either going up by 2 each time, or going up by 4 each time, or 1, or going down by a half, or down by a third. Okay, the absolute value is going to make this v, and the absolute value, you need to remember that everything in here turns to positive. Okay, our piecewise graph is going to have multiple situations here. Okay, so it's going to have a situation where something's increasing and then it stops. So maybe you're walking up a hill, and here you take a rest, and then you decide to walk up the rest of the hill. So that would be an example of like a piecewise graph. Exponential is something that's getting exponentially bigger. I hate to use that word in there, but it's making bigger leaps each time. It's jumping a little, and then more, and then more, and then great amounts at the end. Okay. Most of the time when we're talking about exponential, we do a lot with like interest rates and banking and things like that. And then the quadratic again is going to make, this is called a parabola. So it's either going to make a up and down or down to up shape. And quadratics are mainly in our class, we see it with something that can come up and then falls back down. Like we said, like a rocket shooting off, or a football being kicked up in the air and coming down, those types of situations. So at this point, I just want you to have a very general idea of what each one of these graphs looks like. Okay? And our theme today in class has been the robot, if you didn't notice. So the Terminator is a robot. So he says, I'll be back. I will see you in the morning. Make sure you jot down a few notes about these graphs because we'll be identifying them tomorrow. Have a fantastic evening.